Hold your smartphone in your hand. At its base lies a tiny oval-shaped port, barely 8 millimeters wide, no thicker than a sliver of paper. And yet, right there, inside that almost invisible opening, an entire technological era is operating quietly, silently, but with more force than any laboratory revolution in history. Few people realize that through this microscopic port, you are not merely charging a battery. Power strong enough to drive a 240-watt industrial drill can flow through it in complete silence. At the very same moment, 4K video streams, studio-quality audio, control signals, and billions of bits of data travel simultaneously along a single, unified pathway. If you were to ask someone from the 20th century, how can a hole smaller than a pencil tip do all of this? They would likely assume you were describing science fiction. Yet there is no magic here, only the masterful evolution of materials, geometry, and hardware-level intelligence. Beneath a plastic shell, less than 1 millimeter thick, lies an intricate world of molecular alignment, microscopic printed circuits, and electronic protocols far beyond what intuition would suggest. This is USB-C, a connection port both ordinary and astonishingly powerful, a symbol of extreme spatial optimization in the digital age. Think back to the experience of plugging in a phone charger using the old USB-A standard. You often had to try twice, sometimes 3 times, just to get the orientation right. That minor frustration became a shared trauma of an earlier technology generation. Why would a global standard be designed to be so inconvenient? USB-C solves this problem decisively through rotational symmetry. There is no longer a concept of top or bottom. Every orientation works. This is made possible by an elegant geometric structure, a perfectly symmetrical oval port with 24 contact pins evenly distributed on both sides, each side a mirror image of the other. These pins are not merely physically mirrored, they are supported by intelligent control circuitry embedded within both the cable and the receiving device. The instant you plug it in, the controller detects the orientation, activates the appropriate pins, and precisely routes power and data according to the real-world connection. This orientation agnosticism does not compromise electrical safety or data integrity. That is why USB-C is often described as a two-faced beast, always adaptive, regardless of how it is connected. Geometry here is not just aesthetics, it is an engineering philosophy. This perfect symmetry represents a major leap in human-machine interaction. Technology no longer forces users to adapt, it aligns itself with natural human behavior. If you were to disassemble a USB-C cable and examine it under an electron microscope, you would encounter something remarkable. Within a space half the size of an old USB-A connector, 24 pins are packed with micrometer-level precision. Where earlier standards had only 4 pins, power, ground, data plus,
much
and
clearer
data.
now.
USB-C
Let's
carries an
review the
entire ecosystem
parameters.
of functions. The configuration channel CC allows the cable and devices to exchange configuration data and determine power roles. Superspeed lanes enable data transfer rates up to 40 gigabits per second, supporting 4K and even 8K video alongside lossless audio. The V-bus pins deliver high-power electricity up to 240 watts. Auxiliary pins manage control signals, error detection, and alternate modes such as HDMI and DisplayPort. This increase in density is not achieved by microchips alone, but by advances in material science, ultra-pure copper, interference-resistant polymer insulation, multi-layer electromagnetic shielding. Together, they allow energy and information to flow through a channel scarcely larger than a green pea. The result is transformative. A single cable can replace an entire drawer of wires once cluttered with HDMI, DisplayPort, USB, and proprietary charging cables. One of USB-C's least obvious strengths is that it is not merely a charging cable, It is an intelligent collaborator that negotiates to protect both device and user.
The
In older
control
standards
signal
like
engages the
USB-A,
auxiliary pin,
plugging in
shifting
delivered
the
a fixed,
output into its
low
alternate
power
mode.
level regardless of what
This
the device
allows for
actually needed
specialized
or
data
could safely
transfer.
handle. With USB-C, everything begins with an electronic conversation known as a negotiation protocol. As soon as the connection is made, an embedded marker chip, the e-marker acts as a digital interpreter, initiating a dialogue between charger and device. How much power do you need? I can handle 20 volts at 5 amps. Agreed. Supplying 100 watts. If you connect a power-hungry laptop, the system cooperates to deliver maximum power safely, allowing full performance without risk. If the device is something small, like a pair of earbuds, the cable automatically limits power to the safest possible level. This mechanism not only improves efficiency, but dramatically reduces risks of overheating, short circuits, and electrical failure, a major leap forward in electronic safety. By
When a power
communicating
surge
before acting,
hits, the smart cable
USB-C
immediately
transforms
limits
every
the
charging
flow,
event
keeping
into
your
an intelligent
devices safe
transaction,
and operational.
rather than a gamble as it once was. You might assume that all USB-C cables are the same. In reality,
When you connect a
their
USB
identical
3C
appearance
device,
hides important
the
differences.
power delivery
USB-C is designed to be shape-shifting, beyond standard power and data transfer. It supports alternate modes, allowing the same cable to function as HDMI, DisplayPort, or digital audio with nothing more than a command from the connected device. This is possible because certain pins are multiplexed, meaning their roles can be reassigned. A pin used for data in one scenario can become a video channel or audio signal in another. With a single physical port, you can connect external displays, sound systems, or cameras without complex adapters. However, this visual uniformity conceals a trap. Not all cables include full control chips, adequate shielding, or support for advanced modes. Cheap. Component-reduced cables may damage devices or simply fail to transmit video, despite looking identical to high-quality cables. The warning is clear. Read specifications carefully. Check for e-marker certification, and choose reputable sources if you do not want USB-C's versatility to become a critical weakness. USB-C is not just a connector. It is an optimization problem solved at the intersection of physics, engineering, and human behavior, a form of hardware intelligence where communication precedes action. Its success reflects a new philosophy of design when hardware can negotiate and adapt. The digital world becomes smoother, safer, and more minimal than ever before.